about reference angles, and I hope that the practice yesterday for the coterminal angles went okay in class, because there's going to be a very good connection between a reference angle and a coterminal angle. Because something you are going to really get used to as we go through more trig is that, as we talked about yesterday briefly, you could take an angle and spin that around the origin so many times that you could have multiple upon multiple upon multiple of angles. But in the end, those angles are only related to a particular reference angle. Let me show you what I mean by that. During the coterminal video yesterday, or whenever you watch that, I started with a 30-degree angle. And then I said that it is possible that you have an angle that looks the exact same as this, but it is rotated differently. So if we rotated one time around, we said yesterday that the coterminal angle would be 30 plus 360 degrees, or 390 degrees. And then if you took this angle and spun it around another time from 390, you'd have 390 plus 360 degrees, which would get you 750 degrees. So both of these angles, in a way, are a multiple of 30, because you're going around 2 pi or 360 each time. And so you could call 30 the reference angle, because that is what both 390 and 750 are based on. And so that is one way to consider what a reference angle really is. You're really making your life easier because you're talking about a smaller degree measure. Now, these 4 graphs down here, I'm going to talk about reference angles in all 4 quadrants. So for instance, let's draw a first degree angle, or first quadrant angle. So something acute. So this, based on what we've seen before, would be called theta. And a couple things to know about a reference angle now in this section is that a reference angle is always acute, and it always is related to the x-axis, not the y. So if I read the definition here, it's an acute angle that the terminal side, so this side, makes with the x-axis. So we're talking about the angle from the x-axis to the terminal side. So in the first quadrant, let me just say, let's make up that theta is 60 degrees. That would mean, because 60 degrees is the angle that goes from the x-axis to the terminal side, and because this is acute, my reference angle would be 60 degrees. If I make a second quadrant angle, so I start with my initial side, draw an angle in the second quadrant, let me call this angle theta again, and I'll put the direction that we're moving, and I'm going to say that this is 140 degrees. This time, what we need to think about is if a reference angle is an acute angle, and it has to relate to the x-axis. If we look at the angle that I gave you, it's 140, which is definitely obtuse. However, if we look at this little angle here, does it fit the criteria of a reference angle? Is it going to be acute? Yes. Does it relate to the x-axis? Yes. So if we think about that a straight line is 180 degrees, if this is 140, the rest of it must be 40 degrees, which means that your reference angle this time is 40. In the third quadrant, if I draw an angle, so here's my vertex, initial side, terminal side. This clockwise would be your angle, and I will say that theta equals 210 degrees. Now, if we take a look at the green angle, this is definitely obtuse again, and the reference angle has to relate to the x-axis and has to be acute. So I ask myself, what is the closest x-axis that I see? Well, this looks like a pretty close x-axis, and we know that that is really related to 180 degrees. So if this angle is at 210 and this is at 180, it means that the difference between those two angles is 30 degrees, so 30 degrees would be my reference angle. Last but not least, at least going counterclockwise, if I have a initial side and I have an angle in the fourth quadrant. So that means I would be going from here all the way around. Let's call that theta, and I will call that 300 degrees. Again, the angle that we have is obtuse. We need to make sure it's acute and related to the x-axis. So this looks like the closest x-axis this time. And so if we think about it, all the way around the circle is 360 degrees, which means if I used up 300, the remaining would be 60. So my reference angle would be 60 degrees in that example. So I wanted to do the first couple all in degrees because I think more of you have a good gut instinct with degrees. So we're going to be using radians as well, but before we do so, I want to do 2 more examples. If you have room, I would maybe squeeze these in. Every example I've done so far has been a positive angle. What if I gave you a negative angle? So what if I picked, starting here, what if we had an angle that landed in the 3rd quadrant going this way? So let's say that my theta is negative 130 degrees. What I want you to think about is, again, what is the closest x-axis I can relate to? And the reference angle, remember, has to be positive. This is the x-axis. Let me get green here. This is the x-axis that I'm thinking it relates to. So if you consider that this is really negative 180 degrees, the remaining part of this angle that relates to the x-axis would be negative 50 degrees. Even though the angle is negative here, think of it as the reference angle must be positive. Is this an acute angle that relates to the x-axis? Yes, it is. So in your mind, you can say that the reference angle is really positive 50 degrees because that is the angle you make with your x-axis. In the same way, if I make up an angle that lands in the 2nd quadrant going this way, I will say that this is negative 240 degrees. If I am relating 240 to the closest x-axis, this would be the closest x-axis, or if we're thinking negative, that would be negative 180 degrees. And if this is negative 240 degrees, the distance or the degrees changed from negative 180 to negative 240 is technically negative 60, but if reference angles are always positive, my answer would be 60 degrees. So I hope that gave you a good gut instinct, because now I want to go into actual examples. Determine the reference angle of negative 20. Well, if I do a drawing of that first, that's usually the best way to do it. Negative 20 would be in the 4th quadrant, and my angle would be negative 20 degrees. Does that angle, is it acute? Yes. Does it touch an x-axis? Does it relate to this? Yes, it does, which means that my reference angle would be 20 degrees. Now time for radians. Yes, I have a denominator of 7, so that means that if I'm going to make a common denominator, this would be 0 pi over 7. This is really in terms of pi, which would be 7 pi over 7. Halfway between 0 and 7 is 3.5 out of 7, and then I believe this would be 10.5 pi over 7. So if I graphed this angle, 3 pi over 7 would be still in my 1st quadrant, barely. Does this angle relate to the x-axis? Yes, it does, because it comes from here, and here's my terminal side. Is this angle positive? Yes, it is. So my reference angle is 3 pi over 7. 480 degrees. Okay, let's think about what that looks like. Here's my initial side. I'm going to go all the way around, and I'm going to land here, and that's 360 degrees. So relating to yesterday's lesson, if you're thinking coterminal angles, if you subtracted 480 minus 360, you would get 120 degrees, which means that that is how much is remaining. So if you went around once, that's 360, and then you would go about 120 degrees more and land in the 2nd quadrant. So my angle would look something like that. And this, if you're thinking smaller, would be 120 degrees from here to here, which means that the reference angle cannot be obtuse, but it can relate to the x-axis. So if we've gone 120, that means we have 60 more degrees to go. So 60 degrees would be my reference angle in this case. Again, if someone's wondering where did the 480 go, I subtracted out a full rotation and then wrote down what I had remaining. The next example, also in radians, we have to keep in mind that we have a common denominator of 3. And we're going in the clockwise direction because it's negative. So we have 0 pi over 3 think we did this example last time. This, if in terms of pi, would be negative 3 pi over 3. So this would be negative 1.5 pi over 3, because that's halfway between, and then negative 4.5 pi over 3. Now again, just like the last video, we have to get to negative 11. So let's keep adding 1.5. So we have negative 6 pi over 3, negative 7.5 pi over 3, negative 9 pi over 3, negative 10.5 pi over 3. So where is negative 11 pi? Well, if this is negative 10.5 pi over 3, it is right past it. So if this is my, let me get a different color. If this is my initial side, this is where my angle will land. And so what I really did is I went around one full time and then went and landed right here. And so if we're thinking about reference angles, what's good to consider is what x-axis is this relating to? Because here's my angle. It looks like this time that we're not relating to over here, which deals with pi. It looks like we're relating to this axis, which we can consider 2 pi. Because my angle is so negative, let's think about using coterminal logic. If I take negative 11 pi over 3 and I add 2 pi to see if I can get more of a positive angle, that would really be negative 11 pi over 3 plus 6 pi over 3, which would be negative 5 pi over 3. Can that be my reference angle yet? No, because it's not positive. So I'd have to take negative 5 pi over 3, add another 2 pi, or 6 pi over 3, and I would get a positive pi over 3. Does pi over 3 work with what we're naming a reference angle? Does it relate to the x-axis? It does, because pi over 3 is from here to here. Is pi over 3 an acute angle? Yes, it is. So this is my answer for the fourth example on this page. These examples, I do want to give you a minute to try any of these that you'd like on your own. You might want to start with the degrees, see if you're understanding the process of reference angle, and then go to the radians. So at this time, if you could pause your video, try as many of these as you can, and I will be back with you with my work and explanation. So please pause the video now. Alright guys, so if we take a look at negative 130 degrees, what I did was I determined that negative 130 has to be in the third quadrant because it's between negative 90 and negative 180. Then I said if I'm finding the reference angle, I'm comparing it to the x-axis, which means to get from the negative 130 to the negative 180, I am going a negative 50 degrees more to get to negative 180. But because the reference angle has to be positive, I said the answer was 50 degrees. I know it's a reference angle because it relates to the x-axis and it's acute. The second example, I noticed I needed a common denominator of 5, so I said that pi had to be written as 5 pi over 5. Notice this distance was 5, so I did halfway between each one for the 2.5 and the 7.5. I then graphed my angle, which would have to be in the third quadrant because it's between these two values. Then I thought about reference angle. I said it's related to this axis again, so it's related to 5 pi over 5. How much farther is 6 pi over 5 than 5 pi over 5? Well, you have to go pi over 5 more, which means my reference angle is positive pi over 5. This example, 660, I found the coterminal angle because I had to go around more than one time to land here. So what I did was I found that the coterminal angle was 300. So I thought about that this is really 300 degrees, which means there's 60 degrees left over to get to the x-axis, which is why that was my answer for number 3. And the last example, a common denominator of 4. This would be negative 4 pi over 4. So halfway between would be negative 2 and negative 6. So this angle landed in the third quadrant because the negative 5 is between here. When I thought about my reference angle, I said I'm starting at negative 4 pi over 4, landing at negative 5 pi over 4. So what is that distance? Well, initially it's negative pi over 4, but we need the angle to be positive, which is where I got my answer of pi over 4. related to that x-axis.